Hi, my name is Sharon Sella, software engineer at Base Consulting.
And I'm Howard Piwang, Technical Energy Lead at Base Consulting.
Welcome to the Conversations at the Kaya, episode 13. And today we'll be focusing on a project that Base Consulting conducted with MECS in Uganda and try to get a thorough understanding of what happened. Yeah, so...
Okay, maybe to carry on, I would say one of the good things we did at the pilot, for example, let's imagine a woman cooking beans for 4 hours. You're cooking beans for 4 hours, but generations ago, the same technology that was used by your ancestors is the same thing you're using. So that's a 3-stone fire. Some of the things, of course, that the woman suffers from, there's the smoky conditions in the kitchen, the sore throats, the teary eyes, and so much more. So one of the things that we looked at is, although Uganda has made a lot of transitions towards electric connections, but the biggest hurdle has been in improved cooking. So 93% of Ugandans actually have the similar problem from what creation from the imaginations I've created of a woman having issues with cooking, still using the 3-stone fire. So if 93% of the people are cooking that way, what does this create a gap in? So what we tried to intend with MECS was to do a technology assessment, look at adoptions as well as commercial viability of a pilot that we were trying to intend to do. So yes.
Okay, yeah, okay. Thank you for setting up the context of the study. And I think the first question is, what technology or framework did you use? Because I was reading about battery swapping, and it's often used in electric motorbikes. So how did you think, what was the thinking behind using the same technology in e-cooking?
Oh, nice. So while the technology works in electric vehicles, what is the possibility of it working for cooking? So one of the conditions set for this is, for a while Ugandans try to make momentum towards electric connections. So one of the things that they've tried to do is mini grids. So mini grids are being scattered across different regions in Uganda. So while mini grids are being set up, mini grids mandate is mostly to supply electricity for lighting, charging phones, and then simple appliances. So in these conditions, if at the mini grid you connect, let's say, a load equivalent to an EPC, an electric pressure cooker, what happens? So most times the wires trip or burn out, and then also long term could actually affect the grid. So one of the decisions we come about was, how about the possibility of the mini grid acting as a charge station or an operator to charge a battery. Then the battery is given to a household. So a household is given an EPC that attaches, that uses a battery to charge. That's quite a similar concept as in EVs that we actually see quite much. So when the battery depletes, the household or the woman responsible, the cook who's using the EPC, just calls the mini grid or takes the battery that is depleted and is given a battery that is fully charged. So the concept really works. And from what we tried to do in the pilot, it was very big success. And we saw opportunities that cooking with the EPC that uses a battery worked really, really well, where we shall actually discuss more in the conversation as we go along. Yes.
Okay. So what made you decide on 1.4 kilowatts for the EPC?
So one of the things that we had to do is, through a baseline study, we looked at the size of households, how many meals they cook. So averagely, the size of the households is about 6 to 7 households. So when we do a calibration, also basing on available EPCs, so the most common EPCs, this time we used actually DC, it's not an AC EPC. So the most common DC EPC is about 500. So when we did reverse engineering, we saw that 1.4 kilowatt lithium battery was actually really viable for the pilot. Yes.
Okay,
Yeah.
that's interesting because uh, from the study, so that 96% were happy with the results, but there was a bit of issues or complaints about the longevity of the batteries, with 40%, I think it was 40% complaining that the batteries were getting depleted while cooking.
Yeah, yeah.
Yeah.
So really, that's very good. The physics of the battery really failed us, but the technology itself, as battery swap, cooking using a battery really worked. With about 96% of the people actually saying it cooked almost 99% of the meals prepared in the community. So that is a very big plus. Of course, the biggest challenges were on the battery, and this is something quite similar to electric vehicles. Something called battery. It's called range anxiety in the e-mobility world, but like here now we could call it cooking anxiety. So because of that anxiety, the batteries came with a BMS, battery management system. So a person is actually able to know what percentage the battery is at, and then how much more is left for them to cook. So of course, when you're preparing your normal meal, one of the biggest thing, there's always a stress that comes when you know, okay, oh dang, the battery is actually almost depleting, and yet I'm cooking beans that takes like about 45 minutes. From the battery, it shows that you're left with 15 minutes. So what happens next is people still do the fuel stacking. So at the backyard of their kitchens, you'll find a pile or a bunch of firewood. So people still were cooking with firewood. So while the technology worked, it was able to cook all the meals. Because of the failures of the battery, people still stacked, and people used actually firewood.
Firewood, yeah.
So most
Okay.
of the heavy loads for cooking was they were mostly using the EPC for cooking. So that's mostly beans, meat stew, sometimes the tubers, potatoes, cassava, but like other components, for example, boiling tea, and the other things like roasted meat. It's quite common in this community. Guys do eat roasted meat. So to roast meat, you can't use an EPC. So you just have to set up a flame, then you roast the meat. So there was a lot of fuel stacking. People just use the EPC for the heavy loads, but because of the anxiety, people still stacked with firewood.
Okay, that makes sense. Now, far from the consumers who really benefited from it and were happy with the results, now we are going back to the commercial angle of it, the people who are operating these mini grids. So from the project, I saw that from the pilot, that the revenue generated only covered about 1% of the total operational costs, which is very low. So can you talk more about that?
Yeah, so the commercials, while the technology worked, the EPC was able to cook all these meals. People liked it, and then also maybe something I left out. One of the unique elements was in the battery swaps. So it was quite common that some households actually called the mini grid, and we were delivering the batteries using electric vehicles. So it
Nice.
was really very efficient, and it was more reliable. So it kind of reduced the anxiety of cooking using batteries. But of course, the commercials were really rough. It was really so bad that across all the board, while the DC EPCs were embedded with DMRVs, more of like it was more of a smart EPC. So we were able to track up to about 400 and about 50 cooking sessions. So that brought down to about 200 and about 200 swaps. So because of that, why I say the commercials were rough, the total revenue generated from the pilot was just $57.
Yeah.
So the $57 from just covering operational costs. So the operational costs could include paying maybe the mini grid, the swap operators, and everyone contributed less than 1%.
Yeah.
So why 1%? Of course, one of the hurdles as highlighted was the battery. Battery brought a lot of challenges. Yes. Also, there was a lot of fuel stacking.
Yeah.
So the other element, maybe one of the biggest complaints as well, was was a swap fee. So one of how did we even come up with the different models to meet the commercial viability of the pilot? Maybe that's where I could have started from. So we did a baseline study to look at the home economics, like the household income. So before all that, one of the highlights is while women cook a lot using the APCs. So from the baseline studies and also midline studies, we found that 99% of the women were actually using the APCs.
Nice.
But then who is responsible for transitioning for the, let's say if you want to buy an appliance, it is the head of the household,
yeah.
so it is the man. So when the man is the one responsible, is the one who's managing the wallet, the benefits, the woman knows the benefits of using the APC. The man doesn't know that. So
Yeah,
one
sure.
of the things actually during the deployment phase actually we had to do is, while the woman, when you're doing like a pitch on adoption, accelerating adoption and the use of the EPCs, of course you're going to share the benefits, but for the man, he looks at the finances.
Yeah, the finances.
Does this make financial sense to me? So what we found out was, in the home economics, about households use about $7 for cooking
For
as a
cooking
cook every month.
per month. Okay.
Yeah.
Okay.
So when you're bringing in this technology, you cannot set a swap fee that is beyond the cooking, like the monthly cooking fee.
Okay.
So if a swap fee, let's say, is about, you cannot set a
was-
swap fee
okay.
of $1.
Okay, let me ask. The swap fee was $0.18.
Yeah, so that's
and that
about-
was 1%. So if you do 100, it should be $18 per swap. For it to make
So no, to make
sense,
actually to
financial
make sense, to
to
make for cost
to the operator.
recovery from the models that we looked at, actually was about 10 to 12 US dollars
Oh, okay.
per swap. That is like
It's too much.
that is, if you're doing that per swap, that is almost a 10, not even 1/5, like 20% of the entire household
Yeah.
household income per month. So it doesn't make sense. So long term, if we do per swap in a month, the household will be poor.
Be poor because from the pilot you found that they do about 4 swaps per month.
Yeah. So averagely, so we had assumed before, we had modeled that household should do about 16 swaps per month.
Wow. Okay.
But like at the end, we actually found out like people were actually doing just 4 swaps per month.
Okay, because of fuel stacking as well.
Yeah, so the fuel stacking, and also one of the biggest hurdles we had was on the payment. So we said, from all these, one of the best ways to set up the prices, like from the household, the fuel costs per month, we had to set the swap fee at about 14 cents.
14 cents. Okay, for it.
So it made more sense, but the commercials doesn't make sense. So when you model across for the 5 years, there's no break even at all. So other elements, of course, will come in, but like while the other challenge maybe I've left out was on the payment. So the swap fee, about 14 cents, was paid through mobile money.
Oh, nice.
Or M-Pesa, for example. So we all know that when you initiate about a 14-cent payment on M-Pesa, there is a transaction fee that is implicated to the payment as well.
Oh,
so
yeah,
that means
sure.
that you end up, instead of paying 14 cents, you end up paying like about 15 cents.
Okay.
Yeah, so that was a very big challenge to the house, etc.
So I think, let me ask something, then I'll come back to the other financing mechanism that people always talk about, that is carbon credits. But before you get there, do you think if the same study was done maybe in a city center where people use LPG, that is a bit expensive, maybe they spend $30 per month on cooking, will it be more financially viable?
Yeah, I think so. One of the largest, like the biggest hurdle for all this, like when we said that the cost for fuel in the community where we did the pilot was about $7
per month.
But like when you go to urban areas, even around Nairobi, it could really shoot up to almost, I think, even $20 maybe per month. So that is better. So the biggest hurdle for the community was poverty, which really decelerates the whole transition scenarios. So when you compare that to the urban folks, it's quite very different because they have an existing capital or
Capital, yeah, yeah.
finances or cash flows that could accelerate the transition. So the biggest challenge for all this, it's one, of course, is poverty. But now that also, while everyone is preaching transition to cleaner cooking, there's also something called what, financial transitioning, because you've brought in a new technology. The cost is slightly higher
Higher,
than the
yeah.
previous cost. So for them to move to that, it's impossible
It
nearly.
is, yeah,
It's
yeah,
very
yeah.
impossible.
Okay,
Yeah.
makes sense. Now, on carbon credits, given that the people in the village were using or use firewood, there's a case here to be made about reducing or removing entirely the carbon credits emitted from the
Yeah.
firewood.
Yeah.
So there was a case for getting at least a bit the operator, the mini grid operator,
Yeah.
getting a bit of money
Yeah.
from the carbon credits. What did your study find on that?
Let me use this the new term. The carbon credits math didn't math at all.
Yeah.
So according to the IPCC, they say like if a community, or okay, let's look at a household.
Household,
So
yeah.
a household, when they've transitioned to cleaner, let's say electric cooking, they reduce about 2.5 tons of carbon per household per year.
Oh, nice.
So from our study, it was really sad. So while in real life, the stoves were embedded with DMRVs, were meant to track who is cooking, why they're cooking, how much electricity they've used for cooking. Of course, from our previous conversation, you said people are still stacking.
Mm-hmm.
We were able to just get about 100th of that per year. So that's 0.00256 tons
Tons.
per year per household.
Wow.
So that
Okay.
means the contribution of carbon to the OPEXs were less than 1%.
It's very low
Yeah,
here.
it was really absurd that while maybe the math assumes that we have to achieve this particular variable, so the most variable verified method of calculating these kind of transitions or carbon reductions is through a verifiable means of using DMRVs.
DMRV. Yeah. Okay. Okay. So that's sad.
Mm.
Now I think the last question or the second last question, these mini grids, they what is it? They rely on intermittent sources of energy. That is
Yes.
mainly solar and wind. And I
Yeah.
think yours was working with solar.
Yeah, solar and biomass.
Yeah. Do you think that by just being intermittent, that it led to the idea of battery swapping? What can be done such that we make the mini grids more reliable,
Yeah.
that people don't have to rely on battery swapping, they can connect directly from their homes?
Yeah, okay, that's quite a tough one. So the beauty about where the pilot was conducted was because of the intermittency, and it had both solar and biomass. So the total capacity of the mini grid was almost 80 kilowatt. And the daily load for the mini grid was about 32 kilowatt. That is
32, okay.
supplying the community there and the different households with electricity. But of course, it's quite a similar characteristic across the national grid. During the day, people are really not consuming power. Since the mini grid had solar, that was the best time. Instead of curtailing electricity, that was the best time to use the electricity generated like during this time, like around midday, to charge the batteries. So it gave it a very good. It was a very good thing for the mini grid. Of course, this is someone could actually bring in the role that to accelerate the economics of the mini grid as well. The charging of the batteries really influenced maybe the mini grid, because it's more of like money. So the more batteries charged, the more money and revenues you get in. So while that was done, a bad side that we found about the mini grid was maybe one of the things we actually failed to do before. We realized that the mini grid started undergoing load shedding.
Oh,
So the load shedding was caused by the batteries drawing almost 38% of the previous energy generations. So the mini grid's consumption actually shot up from 32 kilowatts per day to about 48 kilowatts per day.
okay.
Yeah.
Okay, that's fine.
So from what you'd say that why is there a possibility instead of the mini grids improving the infrastructure,
Yeah.
and then the people actually being able to use EPCs
Yeah,
directly.
directly from home. Yeah.
Yeah, so while that is it's quite possible, but the characteristics of all mini grids across Africa is it's not in reality is not going to be that way. The only mind about the businesses, the capex is involved in setting up these mini grids are really high.
Okay.
The improving the structures inside the households to meet minimum voltage is always quite high. So that's why most of the biggest targets are either supplying base minimum, so that's powering the house. You may find some households actually having maybe TVs, which is quite few, but like most people actually use the lights for lighting, the electricity for lighting, and also and basically charging their phones. Yeah, I think it's
Okay.
quite a hard thing. Yeah.
Okay, makes sense. So what next? Are you planning to scale up these projects? What lessons are you taking from the pilot that you will implement in the next
Yeah,
phase?
yeah, yeah.
Yeah.
Oh, thanks for that one. So, while the financials didn't really make sense, one of the things we found, of course, was the batteries. Since the batteries failed us, one of the next features we look at is having better batteries. While the batteries underwent a safety test, but like long term, we also have to incorporate that because we had some batteries actually really failing. The other elements involved having like abandoned financing.
Okay.
So instead of
Paper sweep.
yeah, instead of paying like per swap per day or wherever, like someone just pays at the end of the month at
Oh,
once, and
okay.
that
Yeah.
also helps the cash flows at the operator or at the mini grid who is operating the swap station. Then the other element that we were actually really looking at is when we modeled across for financial viability, we found that if we scaled from the 50 as the pilot looked at to about 500, it will make financial sense, and the break even would actually drop to about 75 years. But now that has to be integrated with, for example, concessional loans from philanthropists or even commercial loans from banks to uh, because we found that household alone cannot
Cannot sustain, yeah, that amount. But
sustain the financials.
are you doing the 500 households with a mini grid as well?
Yeah, so the whole aim of the pilot was looking at gridlock conditions, places where maybe there's load shedding all the time, uh, locations where if you connect a battery, okay, if you connect later an EPC, the wires could actually trip. This is a very common reality on the ground,
Yeah,
which
yeah, yeah.
is something we can't avoid. The mini grids or the national grid, if we compare the national grid, we're still having some of the characteristics where there's a lot of lead shedding in some of the communities. So if we bring in the battery technologies and these kind of studies, long term, we could actually see that people are transitioning from the traditional three stone
Cooking.
to modern cooking technologies.
Awesome. Yeah,
Yeah,
it was
yeah.
nice hosting you. I
All
learned a
right. Thank
lot.
you so much. Thank you so much.
Yeah, thank you.
All right.
See
Bye.
you next time. Bye bye.
Next time.
Yeah, bye.